This is how to guide to construct the VI that you need for this assignment. The first thing is have a blank VI with your front panel and the block diagram. On the front panel, you will need a couple of buttons which you can get from the controls panel under OK button, and you just basically place them on the front panel, and then have another one if you need one. And you can see they're sort of numbered one after the other, so just make sure you remember which one's what. And then also have a stop button, again from that front panel, and you place that on the panel. And also a LED display, which you can grab from numeric from where is it? Display. Yeah, from Boolean display around LED, and you place that on the panel. And finally, a graph. That one you get from the graph option and select a waveform graph, which you place on the panel. So they're all the actual controls. These are the 3 inputs, and this is an output, and so is the LED here. You can change the properties of each one of these by right-clicking and selecting properties, and you should get another menu, pop-up menu with tabs and so forth, where you can change all the parameters, including, like, say, the label, where you can make it visible or not visible, as you can see, and so on. Change the parameters, the labeling on the actual controls or the graph or the LED, and so on. Okay, so once you've done that, as far as the block diagram, as you know, one of the main things you need is a while loop. So in that case, I'll try to show this, which is not showing up on here. While loop, it pops up under structures, and select while loop, and basically encircle the whole set of controls that you created. And that is your while loop, containing all the controls and indicators as you would need them. Now, as you know, to control the while loop, you have a stop button that you connect usually to this point here. But because we're going to use an event structure within this while loop to take care of the controls of the stop and the 2 OK buttons for different functions for the VI, we need to embed that event structure in the while loop. So again, you right-click on the block diagram and select structures and select event structure and place that within the while loop. Now, as you can see, one of the main things that pops up is, or the first section of the event structure is the timeout, and that's usually wired up by a constant you place at the front here by right-clicking and basically connecting a constant. So this is the part, if you noticed, on the running of this VI, where you put a value in here in milliseconds or seconds that you want to do something in here if you don't press any of the buttons on the front panel. So what we want to do in this part is basically display a pop-up message saying please press some of the buttons or controls on the front panel. So again, you look in the functions search and go to dialog and user interface, and in that you select display message, and you basically place that in the timeout and put the appropriate message that you want to display, and that's all you need for the timeout to be able to do that, including the time setting here. for the events of change of any of these buttons is when they change value. Say your first button is the one for the demoing the display of the random numbers. You basically right click on the event structure, add event case, and in that case you select the OK button and select the value change, click OK, and what you see in this drop down menu, other than the timeout, you've got this extra section that you put something to do in here regarding this button that you change value of. So in this case you would add under a numeric function a random number generator, which is hopefully you can see it, it's this one here, and you basically place that on within that event. And then, as you can see, it gives you a number 0 to 1 randomly generated like in time. But you want to do that, say, for 20 numbers or so. So what you need then to do is put another structure within this event, which is like a loop of counting up to 20 times, and it's a for loop. In other words, you count for 20 and then you stop. So again, you right click on the block diagram, go to structures, select for loop structure, and basically embed that within this changed value of the event. So as you can see, this random thing is inside the for loop, and then you place the number of counts here, and the graph you put out on the outside of the for loop and basically wire it up. So that will give you that random generation of numbers. Now the only thing with that is you have to also take some time into consideration, because this will happen very quickly. So you need to put some delay in here. So say every 20 or 50 milliseconds you want to generate the number. And again, to do that, you right click on the functions panel, go to timing, and select the wait option. Basically put it in here, select appropriate constant for amount of milliseconds, and that will delay after every number generated so much time before the next one is generated, and so on. And then in a similar way, for the OK button, you would add another case and have another option in the event structure to blink the LED on and off. Now in that case, I'll just add another event structure there just to show you that. So the stop button 2, value change OK, you can see it's blank. It's recommended to use what they call a flat structure. So if I show you that one, it looks like it's sort of like a film, one slide after another. So you just put that in within the event structure, and this is the first slide what you do, and then if you right click on it, you can do something else. After that one, you can right click on it again and add as many sections to it as you want. In this case, we just want 2, and the first one is basically for this Boolean LED, which in other words, you can wire up true or false to the front of it to make it turn on or off. So true value turns it on, and false value turns it off. The only problem with if you copy this and put it in this section, you would have another LED, but not the same one. So the only other way of doing that is if you watch the video on creating a local variable from a control or indicator, you right click on the actual indicator or control and create a local variable, and what you get is sort of an equivalent to the actual indicator or control, but you can put it in another section and you can wire up whatever other value, like what you did here, to make it work. So in this case, you would obviously wire up a false to turn it off. And again, in the same way as in previous one, because of the timing, you would need to add a timing delay in each one of these, so it gives you 1 second delay. So as you can see, that's basically all these except the stop button. And stop button, you again watch the video on the event structures, and it gives you an example how you actually, instead of just wiring it directly to the stop input here, it becomes part of the value change of the stop button within the event structure. So it basically gets embedded in the event structure, and then you wire it to the actual button. So that should give you enough tips and whatever to construct this VI and make it work. Now, you would say, well, what's the basic functionality of all this? Well, it's basically, I'll just drag sort of a working example of that one. When you run this, basically what it shows you is it's sort of a simulation of you actually getting some sort of data and displaying it on the graph, which is this first loop that you do with the for loop. So it's getting 20 bits of data in some sort of amount of time and displaying it on the graph. And that's no different to using a data acquisition type, card, connecting to your PC, acquiring some sort of temperature, whatever, and plotting it over time. And in the second one here, you're just turning stuff on and off. Well, here you're turning on and off LED, but it could be something else. It could be a light, could be a motor, could be a stepper motor, and so forth. The amount of, for example, on and off times that you select here, you can change as many or add as many as you like and make a sequence of events that you want to create. So this is like a simulation of the real world of control of some sort of instruments or equipment that you might connect to the PC.